vegetative state of a fungus. Like with an avocado tree with its roots, leaves, and the fruit, the avocado itself, mycelium are the vegetative state of a fungus, where, in this case, the avocado would be the mushroom, and the mycelium would be like the roots and the branches, except they are generally invisible to us underneath the ground, collecting, gathering, and then channeling into a mushroom for reproduction. Here you're seeing oyster mushroom mycelium, pearl oyster mushroom mycelium, growing on cardboard spawn, and that thicket of what looks like white, fleshy, cobwebby networks is what we describe as mycelium. And these are used to inoculate wooden dowels, small wooden pills that are coated in this mycelium and will be used to inoculate or infect logs. With these logs, we drill about an inch to an inch and a half deep to fit the size of these wooden dowels. And what will happen is that these wooden dowels will eventually begin to serve as nodes for the mycelium to colonize, consume, and grow into the log. So we take them, place them into the hole, and hammer them. In this case, the oyster mushrooms that we're looking to inoculate are not only your edible variant of oyster mushrooms, but also a native species to the Los Angeles basin. What we found is that these oyster mushrooms are incredibly adept at cleansing lead out of the ground in their ability to trap and absorb it. The Metabolic Studio and many others are beginning to investigate into the abilities of fungi to help with sequestering carbon. These piles of logs, which come from the Angeles National Forest, all the way to tree trimmers dropping off logs and branches that they would otherwise have to pay to dispose. And what we are doing is taking this carbon that's sequestrated in the form of these logs and branches, converting that into fungi, into mycelium, which then break it down. Some of the carbon is released back into the atmosphere in the natural process of decomposition, but much of it is kept in the ground when the mycelium transforms it into forms that the soil itself can hold, that the food web within the soil, the bugs, invertebrates, the microorganisms, they hold this biological net of carbon. And if you can imagine a network of fungi growing beneath our feet, they themselves become the bodies of carbon that hold and sequester underneath, otherwise known as a fungal necromass.